Hello everyone. Now we are starting the next topic of wireless LAN technologies, that is Bluetooth. Bluetooth is a name given to the new technology using short range radio links which could replace the cables connecting portable and a fixed electronic device. Bluetooth replaces cables that connects one device to another with one universal radio link. Its key features are robustness, low complexity, low power and low cost. Designed to operate the noisy frequency environment, the Bluetooth radio uses a fast acknowledgement and frequency hopping scheme to make the link more reliable. Bluetooth radio module operates in the unlicensed ISM band at 2.4 GHz and avoid interference from any other signals by hopping to a new frequency after transmitting or receiving packet. Compared with other systems in the same frequency band, the Bluetooth radio hops faster and uses shorter wavelength. Thus, the Bluetooth is a wireless LAN technology which can connect devices such as telephone, computers, printers, camera without using wires. A Bluetooth LAN is the ad hoc network, that is, it does not use the base station. It is possible to connect the Bluetooth LAN to the internet. This technology is implemented using the IEEE 802.15 standards. Every Bluetooth device consists of the built-in shorter range radio transmitter. The current data rate is 1 Mbps and the bandwidth is 2.4 GHz. So an interference between IEEE 802.11 and wireless LAN and Bluetooth LAN is possible. The Bluetooth specification standard defines a short range 10-meter radio link. The device carries Bluetooth-enabled chip can easily transfer data at the rate of about 1 Mbps, that is megabytes per second, within 10 meters of range through the wall, clothing, and luggage bags. The interconnection between occurs by itself without direct human intervention whenever they are within each other's range. In this process, the software technology embedded in the Bluetooth transceiver chip triggers an automatic connection to deliver and accept the data flow. Since the Bluetooth is the short range with the limited speed and low power technology, it is less attractive to cooperate wireless local area network that are generally powered with the 802.11 wireless LAN technologies. Each Bluetooth-enabled device contains 1.5 square transceiver chip operating in ISM, that is industrial, scientific and medical radio frequency band of 2.4 GHz to 2.48 GHz. This frequency is generally available worldwide for the free without any licensing restriction. The ISM band is divided into 79 channels with each carrying a bandwidth of 1 MHz. Next is Bluetooth networks. Bluetooth defines two types of network, PicoNet and ScatterNet. First is PicoNet. The first type of Bluetooth network is called as a PicoNet or the small net. It can have the most of 8 stations. One of them is called as a master and others are called as a slaves. All other slaves are synchronized in all aspects with the master. A piconet can have only one master station, shows a piconet. A master can also be called as a primary station and slaves are the secondary station. The communication between master and slave can be one-to-one or one-to-many. Note that the communication takes place between the master and slave, but no direct communication takes place between the slaves. Next is scatternet. A scatternet is obtained by combining piconet, as shown in the figure. A scatternet consists of, the figure shows the scatternet that consists of two piconets. A slave of the first piconet can act as a master in the second piconet. It will receive the message from the master in the first piconet by acting as a slave, then delivers a message to the slave in the second piconet. So the same device acts as a slave in the first piconet as a master in the second piconet. Next is Bluetooth layers or Bluetooth protocol architecture. The layers of Bluetooth is shown in the figure. They do not exactly match with the internet layer. So first layer is the radio layer. The Bluetooth radio layer is the lowest defined layer of Bluetooth specification. It defines the requirement of the Bluetooth transceiver device operating in 2.4 GHz ISM band. This band is divided into 79 channels of 1 megahertz each. Second is baseband. The baseband is the physical layer of the Bluetooth. It manages the physical channels and links. In addition to that, other services like error correction, data whitening, hop selection, Bluetooth security are also handled by this layer. The baseband lies on the top of the Bluetooth radio layer in the Bluetooth stack. The baseband protocol is implemented as a link controller which works with the link manager for carrying out the link level routine like link connection and power control. Some other functions managed by the baseband layers are to manage the asynchronous and synchronous link, handle packets and carrying out pack paging and inquiry of to access and inquiry to Bluetooth device in the area. The baseband transceiver applies a time division duplex that is TDD scheme used to transmit and receive alternatively. Therefore, apart from the different hopping frequency, the time is also slotted. Next is frame format of Bluetooth. The frame in the baseband layer can be one of the three types: one slot frame, three slot frame, and five slot frame. So the frame format is three slot frame is shown in the figure. So important fields are: first is access code. It is a 72-bit field which contains the synchronous bit. It also contains the identifier of the master so as to distinguish the frame of the one piconet from another. Second is header. It is a 54-bit field which contains an 18-bit pattern repeating 3 times. Each such 18-bit pattern consists of the following field. First is address. It is 3-bit field, so it can be defined up to 7 slaves, 1 to 7. The 000 address is the reserve for the broadcast communication between the master and the slave. The other address from 001 to 111 defines the 7 slaves. Next is type. This is 4-bit subfield used for defining type of data coming from the upper layer. Next is F. This bit is used for the flow control. F is equal to 1, that indicates buffer is full. That means the device cannot receive more frames. Next is A. This bit is for acknowledgement. Since the Bluetooth uses stop and wait ARQ, only one bit is sufficient to send an acknowledgement. Next is S. This bit is used to hold the sequence number. Next, HEC. This is an 8-bit header error correction field. It contains the checksum for detection of error in the 18-bit header field. Next is data field. The field contains the data or the control bit. It can be 0 to 2740 bit long. It contains the data or control bit coming from the upper layers. Next is cellular telephone system. Cellular phone is the wireless communication just like an cordless phone. In cell phones, distance is not restricted within the home, but one can travel in the city or even the outside of the city without interrupting in communication. The demand for cellular mobile phone is increasing at alarming level, and is likely wired communication will be replaced by the wireless technology. In the cellular system, city is divided into small areas called cell. Each cell is around 10 square kilometers, depend upon the power of base station. The cells are normally though of hexagon because of cell phones are base station use the low power transmitters and the same frequencies can be reused in the non-adjacent cell. Each cell is linked to central location called as a mobile telephone switching office, that is MTSO. MTSO coordinates all mobile calls between an area which consists of several cell sites, the central office. Time and billing information of each mobile unit is accounted by the MTSO. At the cell site, base station is provided to transmit and receive and switch calls to and from any mobile unit within the cell to MTSO. The cell covers only few square kilometer areas, thus reducing the power requirement necessary to communicate with the cellular telephone. In this manner, heavily populated area can be serviced by several stations rather than one as used by the conventional mobile techniques. Cell. The basic geographical unit of cellular communication system is called as a cell. Its shape is hexagonal. The cell have the base station transmitting over a small geographical areas. The size of cell is not fixed. Practically, the shape of the cell may not be perfect hexagon. Next is cluster. A group of cell is called as a cluster. The cluster size is not fixed. It depends on the requirement of particular area. Next is global positioning system. The recent popular application that uses the principle of spread spectrum is the global positioning system, that is GPS. The GPS found its original application in military, but recently it is finding in application in the civilian life such as aircraft or the ship navigation, surveying or geological studies. GPS allows a person to determine a time and his exact location in terms of latitude and longitude and altitude where anywhere on the earth. It is also possible to find velocity of the person. The GPS uses MEO, that is medium earth orbit satellite system, which multiple satellites are orbiting in altitude about 18,000 kilometers over the earth. Principle of GPS. GPS operates in the principle of triangulation. One plane, if we know our distance from the 3 point, then we know the exactly where we are. For example, the user is say 5 kilometers away from the uh, point A, 12 kilometers away from the point B, and 50 kilometers away from point C. If we draw three circles with their centers at the point A, B, and C, then the point of intersection of all circles will be exactly show the position of that particular person. This is the concept behind the operation of GPS, and it is shown in the figure. However, in this space, we cannot draw the circle, so we will have to use a squares. But three squares meet at 2 points, so we have to use four squares, which will make exactly only at 1 point. Practically, GPS will work as GPL work will work as shown in the figure. The orbits of the location of satellites in each orbits are designed in such a way that at any instance of time, four satellites are visible from any point of the Earth. This will satisfy a necessity of four squares required for the exact positioning. The GPS receiver has an which tells the current position of the satellite. It is then signal to the four satellites to measure how long it takes for the signal to return. Based on this time, it calculates your position on the earth. A GPS receiver can also show you the position on the map. Applications of GPS. GPS is used by the military forces. Second is navigation. The driver of the car can find the location of his vehicle. Next is GPS gives the location and database use the information to find a path to the destination. Next is surveying, and last is geological applications. Why to use the spread spectrum in the GPS? The GPS uses spread spectrum signals for the following reasons. The signal from the satellite can be kept away from unauthorized users. Next is the system can operate on the low power. And last is each satellite can use the same frequency band without interference with each other. Next is WiMAX. The long form of WiMAX is Worldwide Interoperability for Microwave Access. It is a wireless communication standard which can provide a data rate up to 1 Gbps. WiMAX refers an interoperable implementation of IEEE 802.16 family of the standards. Applications of WiMAX to provide the portable mobile broadband connectivity. It can be used as an alternative to the cable, digital subscriber line, that is DSL, for providing a broadband access. Next is to provide the services such as voice on IP, that is VoIP, And last is for providing a source of internet connectivity, internet access. WiMAX is capable of providing at home or mobile internet access to anyone across the whole city or even in the whole country. It is relatively cheap to use WiMAX to provide internet access to the remote location. We can use a WiMAX USB modem for the mobile internet device that can provide a connectivity to a WiMAX network. They are also known as the subscriber station, that is SS. Portable units of WiMAX are in the form of handsets similar to the smartphone, PC, USB dongles, and embedded devices into laptop. HTC launched the first WiMAX-enabled mobile phone called as a Max 4G in 2008 only for the Russia. The next generation was made available in America in March 2010. The mobile is capable of carrying out the data and mobile sessions simultaneously. There is no uniform global license spectrum for the WiMAX. However, three license spectrums profile published by the WiMAX forums are 2.3 GHz, 2.5 GHz, and 3.5 GHz. One of the biggest advantage of WiMAX is the high spectral efficiency. This is due to the multiple reuse and smart antennas technology. An inherent problem with the WiMAX is that it cannot operate at the higher bitrate over a long distance. We can get higher bit rates or long distance, but not both at a time. Next is satellite communication. The use of satellite in communication system has become very common nowadays. This is because a satellite can see a very large area of Earth. Hence, the satellite can form a star point of communication net, and it can connect many users together simultaneously. This will include the users that have been widely separated geographically. The construction and launch cost of the satellites are extremely high. The cost is distance insensitive and means cost of short distance satellite link in the approximately same as the long distance link. Therefore, the satellite communication system is economical only where the system is used continuously and large number of users use it. Communication using satellite. An artificial satellite orbit or resolves around the Earth is exactly same manner as an electronic resolve around the nucleus of atom. The path in which the geographical satellite exactly take 24 hours to complete one revolution around the Earth. Therefore, they appears to be stationary. The satellites can be used for variety of purpose depending on the types of application. Satellites are classified into following categories: communication satellite, remote sensing satellite, weather satellite, and scientific satellite. The basic principle of satellite communication is a geostationary communication satellite is basically a relaying station in the space. It receives a signal from one Earth station, amplifies it, and improves the signal quality and radiates signal back to the another Earth station. Such relay system allows us to communicate with any corner of the world. The figure shows the block diagram of the communication system using the satellite. An Earth station transmits an information signal to the satellite using high directional dish antenna. The satellite receives this signal, process it, and transmit it back to the reduced frequency. The receiving Earth station will receive this signal using the parabolic dish antenna pointed towards the satellite. The signal which is being transmitted upwards to the satellite is called as the uplink, and it is normally at the frequency of 6 GHz. The signal which is transmitted back to the receiving Earth station is called as a downlink, and it is normally at the frequency of 4 GHz. Thus, the satellite has to receive, process, and transmit the signal. All these functions are performed by the unit called as a satellite transponder. A communication satellite generally has two sets of transponder, each set having 12 transponders, making it total 24 transponders. Each transponder has a bandwidth of 36 MHz, which is sufficient to handle at least one TV channel. The uplink signal received by a transponder is a weak and downlink signal transmitted by the transponder is the strong. Therefore, to avoid the interference between them, the uplink and downlink frequencies are selected to be different values. The operation of the satellite takes place at the very high signal frequencies in the microwave range. This typical band signal frequencies used the communication satellites are as follows. C band, that is 4 to 6 gigahertz, Ku band, that is 11 to 14 gigahertz, Ka band, that is 20 to 30 gigahertz. The C band frequency of 4 to 6 gigahertz indicates that the downlink frequency is 4 gigahertz while the uplink frequency is 6 gigahertz. One of the advantage of operating at such a high frequency is reduction of the size of antennas and other components of the system. It is extremely important to maintain the position of satellite with respect to the earth. Therefore, the control routines such as station keeping and altitude controls are executed from the control room in the earth station. Multiple access methods such as FDMA, frequency division multiple access, TDMA, time division multiple access, and CDMA, code division multiple access, are used to allow the access of satellite to maximum number of earth stations. The power requirement of the satellite is satisfied by the solar panel and the set of nickel cadmium batteries carried by the satellite itself. Next is geostationary satellite. The satellite orbiting in the geostationary orbit are called as a geostationary satellite. They travel the velocity of revolution of the earth. Hence, the complete one revolution around the earth is 1 day, that is 24 hours. This is the reason why the geostationary satellites appear to be stationary. The satellites are about 36,000 kilometers above the earth's surface. The advantages of geostationary satellites are they are much above the inner radiation belt, which poses a problem to the solar cell of low altitude satellite. The solar cell can get the solar radiation for almost 99% of the orbital period. Therefore, energy storage is not necessary. The Earth magnetic field is weak at the such height. Therefore, the adverse effect of the magnetic fields are absent. The large convergence area. A geostationary satellite is visible from about 42% of the Earth's surface area. Therefore, three communication satellites can cover the entire surface area of the Earth as shown in the figure. The geostationary satellites are mostly used as a communication satellite. The Earth station, which transmit and receive information from these satellites, are relatively simple and low cost. Applications of the satellites using in communication system. The main application of the satellite is the field of communication. The communication of the video signal, TV, audio signals, telephone and satellite phones, and the computer data, that is internet. To gain a meteorological or weather information, the photograph taken by the satellites are analyzed for predicting weather. To monitor the status of earth resource such as land, forest, ocean, we can get very important information about crops, lakes, rivers, forest, fires, etc. To spot out the mineral resources, polluted areas, source of pollution. Next is satellite elevation categories. Satellites are generally categorized into three types of depending on their heights of the surface from the Earth. First is low Earth orbit, that is LEO satellite. Second is medium Earth orbit, that is MEO satellite. And third is geosynchronous Earth orbit, that is GEO satellite. So first is LEO satellite. LEO is the short form of the low Earth orbit satellite. They revolves around the earth in the orbit which are 500 to 2000 kilometers above the earth. The time taken for one revolution around the earth is about 1 to 1.5 hours. They travels at very high speed in order to avoid the falling down on the earth. Most LEO satellites operates in the 1 gigahertz to 2.5 gigahertz frequency range. Motorola satellites based on the mobile telephone system Iridium is the LEO satellite system with 66 satellites. The most important advantage of LEO satellite is due to their low altitude, the path loss is very small. So they needs a less transmission power, small antennas, and hence they are light in weight satellite. The disadvantage is they cover small area of the earth due to their proximity to the earth. They have shorter lifespan, that is few months. Characteristic of LEO satellite: first is low orbit height. Next is the one resolution is completed in 1 to 1.5 hours. Next is low launching cost, low path loss, less transmission power, smaller antennas are to be used, less weight, small round trip delay, cover smaller area of the earth, and short lifespan. Applications of the LEO satellites are scientific experiment, weather forecasting, mobile telephones, and for as remote sensing satellite. Second is MEO satellites. The medium Earth orbit satellite, that is MEO, are such a much lower altitude as compared to the GEO satellite. Typically, MEO satellites operate in the range of 5,000 kilometers to 15,000 kilometers above the Earth. As observed from the Earth, they drift slowly in the longitude, taking about 6 hours to circle the Earth. We need to track them accordingly from the Earth. As they are closer to Earth than GEO satellite, they can cover smaller area on the Earth at a time. However, less powerful transmissions are required to reach them. MEO satellites are not used for the communication applications. They are used for the global positioning system, that is GPS, in which 24 MEO satellites orbits are about 18 kilometers. These satellites are generally operated into 1.2 GHz to 1.66 GHz frequency band. Characteristics are orbit height is medium, time taken for one revolution is 2 to 4 hours, moderated launching cost, moderated path loss, moderated round trip delay, more area of Earth is covered as compared to the LEO satellite, and longer lifespan. Features of satellite system. Communication satellites will have some properties which are different from the point-to-point link. Some of them are due to long distance involved, a substantially long delay, typically 270 milliseconds one way, is introduced. Satellite is inherently a broadcast media, so it is useful for the broadcast application. But the broadcast nature makes the satellite system useless when the privacy is important. So one has to use the encryption if the security is required. The cost of transmitting a message does not depend on the distance to be traveled. Satellite systems have excellent error rate, and satellite service can deploy almost instantly. Next is characteristic of satellite microwave system. Satellite microwave systems have following characteristics. It uses a frequency range between 11 to 14 gigahertz. It supports a bandwidth and 1 to 10 Mbps. Attenuation depends on the frequency, power, antenna size, and atmospheric condition. The signals are affected by EMI effect, jamming, and eavesdropping. The installation of satellite is extremely difficult, and the alignment of the Earth station antennas must be perfectly aligned. The cost of building and launching is very expensive of satellite microwave system. Thank you.